All right, we're going to do 6-3 conditions for parallelogram today. We're going to prove that a given quadrilateral is a parallelogram. There are 5 ways to prove. Actually, there are 6 if you count the definition of a parallelogram. We'll get to that in a minute. But there are 5 theorems that show that a quadrilateral is a parallelogram. These are the first 3. So the first one is if a quadrilateral has one pair of opposite sides parallel and congruent, then it is a parallelogram. So all you need is one pair of opposite sides, but they have to be both parallel and congruent in order to prove that it is a parallelogram. The second way to prove that a quadrilateral is a parallelogram is if the opposite sides are congruent. So you've seen this before in the previous lesson. We talked about if it's a parallelogram, then opposite sides are congruent. You can also use this to prove that it's a parallelogram going the converse. If the opposite sides are congruent, then it's a parallelogram. The next way is if the quadrilateral has opposite angles congruent, then it is also a parallelogram. So that would look like this. And once again, you've seen this before. We did the converse of it in the previous lesson. 2 more. If a quadrilateral has one angle that is supplementary to both consecutive angles, then it is a parallelogram. So for example, if this is x degrees, this would have to be 180 minus x degrees, and this would also have to be 180 minus x degrees. It has to be both angles. If it's only one, then you cannot prove it is a parallelogram. And the last way is if the quadrilateral has diagonals that bisect, then it is a parallelogram. So that looks like this. And once again, this is just the converse of what we did last lesson, okay? So those are the 5 different ways. There's also one more way that we'll do right now. So there are actually 6 ways to prove that quadrilateral is a parallelogram. First way is by definition. Definition says that opposite sides are parallel. Second way is opposite sides congruent. Third way, opposite angles congruent. Fourth way, one angle supplementary to 2 consecutive angles. So x, 180 minus x, 180 minus, 180 minus x, there we go, for that one, and also 180 minus x up here. Next way is diagonals bisect. And the last way is one set of opposite sides congruent and parallel. Congruent, parallel, congruent, parallel. Okay? So those are the 6 different ways. So let's see if these are parallelograms. At first glance, people look at this and say, nah, that's not a parallelogram, but be really careful. You can prove that the 2 triangles are congruent. Okay, so this is congruent to itself. So the 2 triangles are congruent by angle, angle, side. Because angle, angle, side, angle, angle, side. So therefore, opposite sides are corresponding. So corresponding sides are congruent, which means that this is congruent to this, and this is congruent to this. Because if they're congruent triangles, then all the corresponding angles are congruent and all the corresponding sides are congruent. So therefore, if you see here, now we have this and this, and this means that opposite sides are congruent, so it's this one right up here. So it is a parallelogram by opposite sides congruent. So it is a parallelogram. Now how about this one down here? This one's not a parallelogram because you'll look and see opposite sides not congruent. Okay, and these two are also not congruent. So this is not a parallelogram. We cannot prove that it is a parallelogram because opposite sides are not congruent. Okay, and that's it for today. Thanks for watching.